This video is a critical task analysis about land use, land cover classification with Landsat 8 images. We will focus on the area around Sugbong Kogon, northern Misamis Oriental, and demonstrate the process of preparing and classifying raster images. We'll begin with pre-processing the raster image and its layers, followed by training the image for classification. We'll then validate the results using out-of-sample data to assess accuracy. The two main algorithms we'll use and compare are minimum distance and spectral angle mapping. However, maximum likelihood will not be included due to unforeseen technical issues and a lack of time. Finally, we'll discuss the classification results and their implications. A little bit of background on the environment we will be using for analysis.
The machine used is running Windows 10 as the operating system. For the software, we'll be using QGIS version 3.39.9 PRISM. Additional details about the QGIS setup can be found in the following screenshot. While our focus will be on the minimum distance and spectral angle mapping, all algorithms, maximum likelihood will not be compared due to the unforeseen technical issues. Specifically, we encountered an error while classifying raster image. Warning 12. The following signature will be included if using maximum likelihood. Singular covariance matrix, Markov for ID number 4. So we pre-process our image from our zip file, head over to the SCP plugins pressing tab and click Landsat. While we are using Landsat image, select the folder which contains the raster image with the Landsat bands as well as the corresponding MTL file. Enable the DOS1 option to apply DOS1 atmosphere correction. Once done, we would like to select a specific area for clipping, which can be easily do by using the SCP plugins. Click multiple bands feature, we select the area we want.
Let us now make our clip area into a single band set. We head over to the SCP plugin, select clip layer bands, and add them to a band set. We can then choose to write that band set into a memory or onto the disk. We can also do both, but in this case, we choose to write to disk for the future use. Click Run once ready. Let's slow down and watch as I clean up, organize the interface. We choose this false color band combination 5, 4, 3 to easily identify the boundaries of the vegetation. Let's first initialize our .scp file to contain the training into for our data. Okay, so now we can start training for classification. But first, we have to specify to the SCP plugin which layer to train on, which choose the layer Sugbong Kogon as that is what we have. We use ROI drawing tools to choose what data to train on and add that to training input.
We did our classification by making four main classes: water, vegetation, soil, and buildings. We also want to change the main class colors with colors that closely resemble real life so as to improve their natural look and interpretability. Water is blue, vegetation is green, soil is brown, and buildings as red as human activities are considered unnatural. We can now classify our data with both minimum distance and spectral angle mapping. Head over to the SCP plugin classification tab. Select the band set which you use for your training. In this case, we use band set 2. Check MCID, select the algorithm to use, check both LCS and algorithm options for land cover signature classification. Once ready, click Run and save the result to your disk. Repeat for other algorithms. Let's initialize our validation.scp file. To easily differentiate between validation and test data, we change the color for training data to yellow. We can now select data for validation. Ensure that none of the data overlaps with training to maintain out-of-sample integrity.
So let's now discuss over our results. First off, we have our minimum distance algorithm. It resulted in having an overall accuracy of 97.67% with a kappa value of 0.959. Next would be spectral angle mapping. We have an overall accuracy of 97.95% with a kappa value of 0.96. We can say that our spectral angle mapping algorithm here is the better model for our data.